Good day, grade 12 learners. Welcome to today's Physical Sciences lesson. My name is Dimpo Rampora, and this lesson is brought to you by the Northern Cape Department of Education in collaboration with Phakama Research and Development. For today's lesson, we are going to be looking at the knowledge area matter and material, and we are going to be looking at organic molecules, part 2 of organic molecules. Specifically, we are going to zoom into physical properties of organic compounds. Right. Now, the following are our lesson objectives for today's lesson. By the end of the lesson, you need to be able to define the boiling point, melting point, and vapor pressure. You need to be able to name and explain the different intermolecular forces that are found in different organic compounds. The other name for intermolecular forces is the van der Waals forces, and you need to name them as dipole-dipole forces, induced dipole forces, or London forces. You also need to name them as what? As hydrogen bonds. All right. You also need to be able to, when given an example from the different functional groups or homologous series, you need to be able to explain the relationship between the physical properties in terms of the strength of the intermolecular forces that are present. We also need to be able to explain in terms of the type of functional groups or the types of homologous series. You also need to be able to explain in terms of the chain length, or in terms of the branch chains, as well as in terms of the energy required to overcome the strength of the intermolecular forces. All right. And last but not least, you also need to be able to explain the effect of intermolecular forces on the boiling point, melting point, and vapor pressure. You also need to be able to identify which intermolecular forces are present in which organic compounds. If you will be able to do that, then you'll be able to know our lesson for today. Now, without wasting more time, we need to look at the prior knowledge that you must have known from grade 11. What is it that you must know in grade 11 for you to prepare yourself for this topic? All right. In grade 11, you should already know how to name and explain the different types of intermolecular forces. So it's not the first time you'll be seeing the word intermolecular forces, because we have done it in grade 11. But in grade 11, you were looking at the mutual induced dipole-dipole forces, or the London forces, and we explained this in grade 11 as forces between non-polar molecules. You still remember when you were doing polar and non-polar molecules? That is exactly what we are going to be looking at when we are referring to London forces or induced dipole forces. We'll be looking specifically at the non-polar molecules rather. You also looked at the dipole-induced dipole forces. Here, you still remember you looked at the forces that were between polar and non-polar molecules. All right. You also did hydrogen bonding or hydrogen bonds. Here we were looking at the forces between molecules in which hydrogen is covalently bonded to either nitrogen, oxygen, or fluorine. All right. You also looked at ion dipole forces. So you looked at different types of intermolecular forces. In ion dipole forces, you looked at specifically the forces between ions and polar molecules. You didn't stop there. You also know in grade 11 already you have done this. You know how to describe the differences between intermolecular forces as well as interatomic forces, which are also known as the intramolecular forces. So you know the differences between intermolecular forces and intramolecular forces. Okay, I've already put a diagram for you over there so that you can memorize and remember what you have learned in grade 11. Remember, intermolecular forces are the forces between the molecules, and interatomic forces or intramolecular forces are forces between atoms. Okay, as you can see, that will be the force between carbon and hydrogen, as well as the forces between this carbon and that hydrogen for interatomic forces. But when you are looking at intermolecular forces, remember it is the force between one molecule and another molecule. I hope you can still remember the differences between that. You also in grade 11, we did a lot about this chapter in grade 11. You also should know how to state the relationship between intermolecular forces and molecular mass. For nonpolar molecules, the strength of the induced dipole forces increases with molecular size rather. I hope you can still remember all of this. You also should know by now how to explain the effect of intermolecular forces on boiling point, melting point, as well as vapor pressure. But last year or in grade 11, you looked at also solubility. All right. You also should know how to define the boiling point, the melting point, the vapor pressure, as well as solubility as according to the exam guideline for grade 11. All right. Now that we have indicated what is it that you should know, now let us look at our prior knowledge activity or our baseline activity to test what you already know from grade 11. Now, this question was taken from a previous question paper from grade 11. Let us see if we can answer it. The question says to us, the graph below shows the boiling point of hydrides of group 5 or Roman figure 5 in the periodic table versus the relative molecular masses. Right, as you can see from my graph, I have across the y-axis the boiling point, and across my x-axis I have the relative molecular mass. All right, now let us see if we can answer the questions that are given to us. 3.4 says, from the graph above, deduce and then write down the name of the hydride, okay, with the weakest intermolecular forces. Now we have to remember what is the relationship between the intermolecular force and the boiling point. We know that the strength of the intermolecular forces, as you increase the intermolecular forces, as they increase, then the boiling point will also increases. So the stronger the intermolecular force, the higher the boiling point. The lower the intermolecular force, or the weaker rather the intermolecular force, the lower the boiling point. So the question wants us to see which one has the weakest intermolecular force. So that means we are going to look at the one that has the lowest boiling point. As you can see here, H2S is the one that has the lowest boiling point. Okay, as you can see, it is negative 60, which is negative 60 degrees Celsius. That is the boiling point of hydrogen sulfide. Okay, let's write the name. Remember, the question was saying we must write the name. It didn't say we must indicate the formula. So as you can see, you must know, the formula, and you must also give the correct name. So the correct name here will be hydrogen sulfide, IDE at the end, because there are two elements in the compound. Now let's quickly move on to the next question. 3.4.2 says, with identify or write down the name of the hydride with hydrogen bonds between molecules. Remember, we have learned in grade 11 that substances that have hydrogen bonds between them, they must be substances that have reacted when hydrogen has reacted with either nitrogen, or it has reacted with what? With oxygen, or it has reacted with what? With fluorine. All right. Now we need to look at that substance here. As we can see here, there is no fluorine, there is no nitrogen. However, we do have oxygen. Hydrogen has reacted with oxygen there. That indicates that that is the one that has hydrogen bonds. All right. So water is the correct answer. Why am I writing water? I'm writing water because the question wanted the name. If the question wanted the formula, then I was going to write H2O. I hope we are still following, guys. All right. Let's move on to 3.4.3. It says, write down the name of the hydride that requires the most energy to undergo a phase change. Now, the substance that will require more energy would be the one that has stronger intermolecular forces. And the stronger the intermolecular force, the higher the boiling point. So from here, which one has a higher boiling point? It is still our water. Water has a higher boiling point, which means that it has stronger intermolecular forces, and hydrogen bonds are stronger intermolecular force. So the stronger the intermolecular force, the higher the boiling point. So it will then need more energy to do what? To undergo a different phase change. So the correct answer here would be water. Okay, remember we write water because the question was asking for the name. It was not asking for the formula. Now let's quickly move on to 3.5. It says, refer to the intermolecular forces and the energy. Give a reason why one of the hydrides of group 5 deviates from the trend in the boiling point observed from the others. As you can see, if you can see that which one between 1, 2, 3, 4 hydrides is deviating from the boiling point, you can see that H2S is over there, followed by H2SE, followed by H2TE. You can see that those ones, they are following the trend, that the boiling point increases as the molecular mass also increases. But the only one that deviates is what? Is water. Why? Because water consists of hydrogen bonds, and hydrogens are the strongest intermolecular forces, and therefore more energy will be required to overcome those intermolecular forces. So I'm not going to write down the answer here, but you can write it down as I am indicating. So the one that is going to deviate will be H2O or water. Why water? Water consists of strong one-sided hydrogen bonds, not rather one-sided. We can just say they consist of hydrogen bonds, and they will require more energy to overcome the intermolecular forces. All right. I hope we are still together there. Here are all your answers. My answers, I already given you the answers. I said water has a boiling point that is much higher than the other 3 hydrides due to the presence of the strong hydrogen bonds, and therefore more energy will be required to overcome the intermolecular force. I hope you guys are still with me, and then we are done with the prior knowledge activity. Now let us focus on what is it that we must know in order for us to understand better the physical properties of organic compounds. Remember, amongst other definitions that we have learned in part 1 of organic molecules, you know, your saturated and unsaturated hydrocarbons, homologous series functional groups, all these other definitions, they are together with this one. Okay, we are just adding to say, in addition of all the definitions that you know in this chapter, you also need to know how to define the melting point. Remember, our definitions are exactly according to the exam guideline. The melting point is the temperature at which the solid and the liquid phases of a substance are at equilibrium. All right, that is very important to remember. And then you also need to know how to define the vapor pressure as a pressure exerted by a vapor at equilibrium with its liquid in a closed what? System. Please make sure that your definitions are according to the exam guideline. And then lastly, the definition that we need to know is the definition of the boiling point. We are going to define the boiling point as the temperature at which the vapor pressure of the substance is equals to the atmospheric pressure. Now that we know all these definitions, the next thing that we are going to do is to look at how are we going to unfold or unpack our lesson today in terms of the physical properties of the organic compounds. Let us now look at the concepts that we need to unfold under the topic physical properties of organic compounds. Right. The first thing that we are going to do, we are going to look at the melting point, the boiling point, and the vapor pressure. Then we are going to be looking at the relationship between the physical properties of organic compounds. We are also going to look at the relationship of physical properties of organic compounds in terms of their strength of intermolecular forces, and we will unfold about the different intermolecular forces that we need to focus on in grade 12. Now we are also going to look at intermolecular forces. I've already indicated that, and we are going to look at the concept in physical properties as a whole, so that when you get into the exam room, you know exactly what is required of you. And I didn't indicate here on my concept map that we are also going to look at some exam tips as to what is it that you have to do when you are dealing with this question. All right. Now, without wasting any more time, let us look at the 3 physical properties of organic compounds that you need to know is the boiling point, the melting point, and the vapor pressure. We already looked at their definition. What is next that is important is that you need to know the relationship between the boiling point, the melting point, and the vapor pressure. Now, the relationship is like this. The higher the boiling point, okay, then the higher the melting point, but the lower the vapor pressure. So if you know this relationship, you would know that as the boiling point is increasing, my melting point is going to also increase, but my vapor pressure is going to decrease. But what makes that, okay, the increase or decrease in the boiling point is also influenced by the strength of the intermolecular forces. What does that mean? As the strength of the intermolecular forces increases, the boiling point will also increase, and vice versa. All right. If the strength of the intermolecular forces increases, therefore the melting point will also increase, and also vice versa. However, when the strength of the intermolecular forces increases, the vapor pressure will always decrease. I hope you understand that relationship. Now, without wasting any more time, how do you then identify which intermolecular force, or how will the boiling point increase or decrease? We said we are going to look at the type of intermolecular forces present, but what is key is for you to know which organic compounds are under which or consist of which intermolecular forces. So there are three intermolecular forces that we need to know of. We need to know of the London forces or induced dipole forces, okay? Or we also need to know rather about the dipole forces as well as the hydrogen bonds. Like I have arranged my intermolecular forces from the weakest to the strongest. So the weakest intermolecular forces would be London forces, followed by the dipole forces, and the one with the strongest intermolecular forces would be hydrogen bonds. Now, what you must remember, we said the stronger the intermolecular force, we already said that the higher the boiling point, the higher the melting point, as well as the lower the vapor pressure. The next thing that you need to know is which organic compounds consist of which intermolecular forces. I must make a disclaimer that all the organic compounds, they consist of London forces, all right? But in some cases, there are more London forces are weaker, and then there are other intermolecular forces that are stronger than the London forces. We will see when we get to that shortly. That, as I said, London forces, we have our alkanes, alkenes, as well as alkynes, and under dipole forces, remember the dipole forces, these are the second strongest, all right, intermolecular forces. They also, these substances also consist of what? Of London forces. So we have London forces and dipole forces, but the dipole forces are more dominant, or should we say they are more stronger than the London forces. All right. So we have the aldehydes, ketone, haloalkanes, as well as esters. And then lastly, we have our hydrogen bonds, and also hydrogen bonds, these intermolecular, these organic compounds also consist of London forces as well as dipole forces, but the hydrogen bonds are more stronger than the other forces. So that is the one that is more dominant in these organic compounds. So alcohols will be one-sided, consist of one side of hydrogen bonds, and carboxylic acid consist of two sides of hydrogen bonds, which indicates that the carboxylic acids are the strongest of all organic compounds that we know of. All right. Now, a way to help you remember this, I made a small abbreviation, AAA. As you can see, there is my AAA over there. All my alkanes, alkenes, alkynes, AAA, they are all under London forces. All right. And then AAA, Hake, A, and C. All right. So once you remember just these abbreviations, or should I say just these alphabets, they will help you remember. Hake will be your dipole forces. All right. dipole forces. And then A and C would be A and C, which is your alcohol, and your carboxylic acid would be your hydrogen bonds. I hope this method that I just showed you is going to assist you to remember which organic compounds consist of which stronger intermolecular forces. All right. Now, there are factors that are affecting the strength of the intermolecular forces. Please remember that IMF represents intermolecular forces, but when you write it in your books or in the exam, please do not abbreviate it as IMF. You must write it in full as intermolecular forces. All right. Now, there are factors that are affecting the strength of the intermolecular forces, which is what? The type of the functional group or the type of the homologous series. We have seen previously that alkanes, alkenes, alkynes, they are different homologous series and they fall under the same intermolecular forces, which should be London forces, or they consist of London forces. All right. So the strength of the intermolecular forces or the type of functional group that you rather have will determine the strength of the intermolecular force. As we have done the AAA, Hague, ANC, we know that haloalkanes, aldehydes, esters, and carboxylic acid, they consist, rather not carboxylic acid, and esters, carboxylic acids, aldehydes, and ketones, they consist of what? Of dipole forces. I hope you still remember that. Now, we are saying for compounds with comparable molecular masses, okay, the functional group will be the determining factor. Okay, so if you have two different organic molecules that have different functional groups, then you are going to compare their intermolecular forces. Say, for example, you are comparing here, I made an example, butane and propan 1-ol. As you can see, butane is an alkane and butan 1-ol is an alcohol. So when you are given an example like this, this indicates that the strength of the intermolecular forces is determined by the type of the functional group that you have or the type of the homologous series that you have. Alkanes, they consist of London forces, and alcohols, they are one-sided hydrogen bonds. That is actually what we meant when we said there are factors that are affecting the strength of the intermolecular forces. What you also need to know is which one, if you are given an experiment type of question, what would be your dependent variable and what would be your independent variable. Please remember that your dependent variable will always be either the boiling point, the melting point, or the vapor pressure. Why am I saying that? It will depend on what the examiner is investigating. If learners are investigating or the question is investigating the boiling point, then the boiling point will be the dependent variable. If it's about the vapor pressure, then the vapor pressure will be your dependent variable, because the boiling point or the vapor pressure or the melting point, they depend on the intermolecular forces, or they depend on the homologous series, or they depend on the type of functional groups that are present. I hope we still remember all of that. All right. Now, there are also other factors that affect, okay, what happens if you have organic compounds that belong to the same intermolecular force, or they belong to the same functional group, or even homologous series. This is where we are saying if they are from the different homologous series, there are different ways that we are going to compare it. But before we look at that, let us continue and look at an example of how we would expect you to compare the strength of the intermolecular forces when you are looking at the functional groups or the homologous series. All right. As I said, here's an example here. I am comparing butane and propan 1-ol. The first thing that I need to do is to identify that, okay, these two are from different homologous series, because butane is an alkane, as I already mentioned, and propan 1-ol is an alcohol. By just indicating that, I already know that butane consists of London forces, or the other word is the dispersion forces or the induced dipole forces. All right. But propan 1-ol, because it's an alcohol, it consists of one side, not two side. Please excuse my spelling there. That was supposed to be one side of hydrogen bond. All right. And then the one side, again, this is supposed to be one side of hydrogen bonds are the ones that are stronger than the London forces or the dispersion forces, or also known as the induced dipole forces. Why am I saying all of these? They represent the same type of intermolecular forces. So if you speak London forces, you are speaking about dispersion forces. If you speak induced dipole forces, you are also still talking about London forces. And that is how you are required to answer the question. All right, when you are given different types of homologous series, how do you answer that question? You first talk about the intermolecular forces that are present. Here we said butane consists of London forces. Propan 1-ol speaks to the one-sided hydrogen bond, and the one-sided hydrogen bond are more stronger than the London forces. So what do? You compare the strength of the intermolecular forces, and lastly, you talk about the energy that is required to overcome the intermolecular forces. So it's most likely that we will need more energy to overcome propan 1-ol because it consists of stronger hydrogen bonds. I hope you can see how we are answering that question. Now, there are also other factors, as I already mentioned, that are affecting the strength of the intermolecular forces. I said, what happens when you are given organic compounds that belong to the same intermolecular force, or they belong to the same homologous series or functional group? You are going to look at their surface area, you are going to look at their chain length, you are also going to look at the type of the molecular mass that you are given. Now, the length of the carbon chain or branched molecules is going to assist you to determine which one will be stronger, which one consists of stronger intermolecular forces than which one, or it will be the one that is assisting you to determine the strength of the intermolecular forces. All right. For compounds that belong to the same homologous series, the larger the surface area, the higher the boiling point. Okay. The longer the chain length, the higher the boiling point, the higher the melting point, and the lower the vapor pressure. All right. Now, just quickly, let's go back there. I want us to look at how can the examiner ask this type of a question. They can also ask it in terms of the investigative type of question. And when that happens, you look at the dependent and the independent variable. As I've already said previously, I said the dependent variable will either be the boiling point, the melting point, or the vapor pressure, just depending on what you are investigating. But the independent variable in this case, it is no longer going to be homologous series. It is no longer going to be functional group, because as you can see, my example here, I have methane, ethane, and propane, and all of them are what? Are alkanes. So that means the type of functional group or the type of homologous series was used as a controlled variable because that one had remained the same. But what was different amongst these three organic compounds or alkanes is that their chain length is not the same, because minth indicates that you only have one carbon, eth is 2 carbon, and prop is 3 carbons. So as the chain length increases, the strength, as you can see, the strength of the intermolecular forces also increases. All right, you can see that the compounds, the strength of the boiling point also increases, rather the boiling point increases as the strength of the intermolecular forces also increases. In this example, what makes the strength of the intermolecular forces increases is because the chain length, okay, or the surface area or the molecular mass is what is different. So the longer the chain length, the higher the strength of the intermolecular forces, or the intermolecular forces becomes stronger. All right, I hope that will help you. Now let's see, how would you explain this question if you were asked to explain the trend, because you cannot answer it the same way as you have answered the one where you were given the homologous series. All right, if we were the one that had different homologous series, here we have the same homologous series. As I already said, A to C, they are all alkanes. If they are all alkanes, we are now going to look at the strength of their chain length. We are going to look at their chain length rather. We are also going to look at their molecular mass. We are also going to compare their surface area. So here, the chain length, the molecular mass, or the surface area does what? Increases. They increase from where? From A to C, as you have said, from compound A to C, the chain length or the molecular mass or the surface area increases. Now, what happens when that happens? The strength of the London forces also increases from A to C. Then more energy will be required to overcome the stronger intermolecular forces. All right. Now remember again here, when you answer the question, you can just use ICE to help you structure the important things that must be in your answer as you are answering. Remember, I will be intermolecular force. You must talk about the intermolecular forces that are present. You must be able to compare their strength of the intermolecular forces and talk about the energy required to overcome, okay? To overcome the strength of the intermolecular forces. If you have weaker intermolecular forces, then you will need less energy. If there are stronger intermolecular forces, then you will require more energy. And that is how you answer the questions. All right. Now that we have looked at the different ways in which the examiner can structure this question, I want us to look at a previous question paper, an activity from a previous question paper. Let's see if we can use the knowledge of what we just learned right now and apply it in this activity. Now, let's look at what the question is saying. The question is saying the relationship between the boiling point and the number of carbon atoms in a straight chain molecules of alkanes, carboxylic acids, and alcohols is investigated. Then you are given curves P, Q, and R are obtained. Right, before we can go to the question, we first need to interpret, or we need to diagnose the graph that we are given. We are given a graph of boiling point versus number of carbons. As you can see, across my x-axis here, I have the number of carbons, and across my y-axis here, I have the boiling point. That means I'm looking at as the number of carbons increases, what happens to the boiling point, right? As you can see over here, I have curve R, Q, as well as P. What do you see happening here? As the number of carbons, here you have 1 carbon, 2, 3, 4, 5. That would be the number of carbons increasing. As the number of carbon is increasing, that means the chain length is also increasing. All right. As the chain length is increasing, what are we expecting to happen to the boiling point? The boiling point must also increase. As you can see, the boiling point is increasing as the number of carbons are increasing, or as the chain length is increasing. Now, what makes the boiling point to increase is because the strength of the intermolecular forces increases as the chain length also increases. If we have that in mind already, we can be able to identify what will be Q, what will be R rather, what will be Q, and what will be P based on the homologous series that we are given over here, right? We are given alkanes, carboxylic acids, and alcohols. So we can just look at the graph. From the graph and my knowledge of alkanes, carboxylic acids, and alcohols, I know that alkanes have the weakest intermolecular forces, which means that they are made up of London forces, or they consist of London forces. And if they are weakest intermolecular forces, therefore their boiling points will be lesser. So according to curve R, Q, and P, which one has a lower boiling point? P is the one that has a lower boiling point than the other curves. Therefore, P, according to me, would be what? Alkane. Will be an alkane. And then from the alkane, now I have to check which one will be the carboxylic acid, which one will be the alcohol. What do I know? I know that the carboxylic acids and alcohols, they all have hydrogen bonds. However, the strength of the hydrogen bonds are not the same. Alcohols have one side of hydrogen bonds, while carboxylic acid have two sides of hydrogen bonds. So which one is stronger? We said earlier that carboxylic acid is the strongest of all intermolecular forces because they don't just consist of hydrogen bonds, but they consist of two sides of hydrogen bonds. So let us quickly say, then that concludes to say R would be my carboxylic acid. Okay, and then that will leave Q as my alcohol. Okay, I hope you have seen how I arrived at my interpretation of my graph before looking at the questions. If we have done interpreting that, then we can quickly go to the question, and you will see that the moment we go to the questions, some of the answers we already answered them as we were going through or as we were interpreting our table. Rather our graph, I meant to say. 6.1 says, define the term boiling point. We already know that the boiling point is the temperature at which the vapor pressure is equals to the atmospheric pressure as according to the exam guideline. Please make sure that your definitions is according to the exam guideline. I'm not going to write that down because we already gave that definition to you. Let's quickly look at 6.2. It says, for Kev P, okay, we already know that P is alkanes. They say to us, write down a conclusion that can be drawn from the above results. Okay, so from the above results, I'm not looking at the other curves. I'm only looking at curve P. What can I say about the relationship between the chain length and the boiling point? What is going on? We can see that as the number of carbons are increasing, what am I increasing? I am increasing the chain length. The chain length of a straight chain also increases. And as that happens, the boiling point also increases. All right. So that could be your conclusion, that as the boiling point increases, as the chain length increases, or as the chain length increases, the boiling point also increases. All right. That could be your conclusion. I'm not going to write it down again here because I don't have much space. Let's quickly look at 6.3. It says, identify curve P, Q, or R that represents each of the following. All right. Can you see that already by interpreting the graph, I am now able to just take the information that I wrote on the graph and just put it over there. They want to know which curve represents alkanes. We said that the curve that represents alkanes is what? Is curve P. Why curve P? Because curve P is alkanes. Why? Because they are the ones that are having the lowest boiling point. The lower the boiling point, the weaker the intermolecular forces. And which intermolecular forces does curve P have? It is alkanes. All right, it's London forces. And London forces, we have that AAA, alkanes, alkenes, as well as alkynes. Now let us look at the next question. Which curve will represent a carboxylic acid? I've already indicated that the one that represents a carboxylic acid would be R, right? R will be the one that represents the carboxylic acid, and obviously Q will be the one that representing what? The alcohol. So if I were to add the question here, I'll say for alcohol, graph Q is the one that is going to represent the alcohols. Guys, I hope we are still together, how I arrive at the answer and what is the relationship between the strength of the intermolecular forces, the type of the homologous series that you have, because that is what we are currently dealing with. All right. Now let's quickly look at 6.4. It says, explain the answer to question 6.3.2 by referring to the type of intermolecular forces present in alkanes, carboxylic acids, as well as alcohols. We also need to be able to explain in terms of the relative strength of these intermolecular forces and talk about the energy needed. So can you see already the examiner has guided you using my method, which is ICE. So you talk about the intermolecular forces present in each compound. We compare their strength, and then we talk about the energy required to overcome those intermolecular forces. So let's quickly do it. We are going to say for alkanes, they have what? London forces. Alkanes are made up of alkanes. Sorry, over there. Alkanes. That must be E. and then that does not exist. Alkanes are made up of what? Of London, or they consist of what? Of London forces. And then what about carboxylic acid? Carboxylic acid, or shall we just put them how from the weakest to the strongest? Let's go to alcohols. Alcohols, they have one side of hydrogen bonds, hydrogen. And then lastly, your carboxylic acids, they have what? They have the two sides. They have two sides of hydrogen bonds. All right. Over there, we also have bonds, okay? Excuse my handwriting, guys. So now that I have identified, so that's one mark, that's one mark, that's also another mark. So I already have 3 out of 5 by just identifying the type of intermolecular forces that are present. And then next, we need to talk about the strength of the intermolecular forces as well as the energy needed. So because I don't have space, I'm quickly going to go to my marking guidelines so that I can show you how must you put it together all together and how the examiner is going to mark you. 6.4, I said alkanes, they consist of London forces. For you saying that, you already have 1 mark, okay? And in addition to London forces, dipole forces, each alcohol consists of hydrogen bonds. Remember, I said that all organic compounds consist of London forces, and some they consist of London and dipole forces, and others such as carboxylic acid and alcohols consist of London forces, dipole forces, as well as hydrogen bonds. But because hydrogen bonds are the strongest of intermolecular forces, therefore that's what makes alcohols or carboxylic acid to be stronger than other organic compounds. I hope we are still together there. And in addition to London forces and dipole forces, I said carboxylic acid have 2 sides of hydrogen bonds. That is also another mark. Then the next thing, we need to compare the strength. What did we say? The intermolecular forces of carboxylic acid are stronger than that of what? Of alcohols and of alkanes. You need to compare, all right? Remember our eyes. Our eyes, you talk about the intermolecular forces. C, you compare the strength of the intermolecular forces. And lastly, you talk about the energy. What do we say about the energy? We will say more energy is needed to overcome the intermolecular forces in carboxylic acid than in the other two compounds. All right, as I've already indicated that. Now you are going to say more energy is required to overcome. Remember, we overcome the intermolecular forces. We don't break any bonds, but we overcome them. All right, that is very important. The intermolecular forces of carboxylic acid. Why? Because they are 2 sides of hydrogen bonds and they are the strongest of all intermolecular forces. Therefore, their boiling point is going to be higher than the other 2 compounds. I hope you guys are still with me, and let us quickly look at your homework. Isn't it that you saw how I have looked at the different method at which the examiner might ask you the question? And then we also looked at an activity together. So I want you to take this time to just take a screenshot of our homework, and then you can try and do it alone with yourself, by yourself, and try and see if you can answer the questions. I hope you have already taken a screenshot of our homework, and then after we are done with that, we are quickly going to move on to what are the exam tips in these topics. What is it that I must know when I am dealing with this kind of a question? Now, I have differentiated them according to 3 tips that I want you to know. So the first tip I want to tip you on how to explain the relationship between the physical properties and intermolecular forces. Which physical properties again are we referring to? We are referring to the boiling point, the melting point, as well as the vapor pressure. Remember, what is the relationship? The higher the boiling point, the higher the melting point, the lower the vapor pressure. What makes the boiling point higher is because of the strength of the intermolecular force. The stronger the intermolecular force, the higher the boiling point. The weaker the intermolecular force, the lower the boiling point. The lower the boiling point, the higher the vapor pressure. All right. Now, you need to be able to compare the structures in terms of chain length. Remember, we have looked at that, and the number of branched, okay? If you are given a branched or a straight chain, okay? A straight chain and a branched chain, which one will have a higher intermolecular or a higher boiling point? The straight chain will take preference over a branched chain. Why? Because the chain length or the surface area is greater in a straight chain as compared to a branched chain of the same organic compound. I hope we are still together there. You also need to be able to compare the strength. As we have seen, as we were answering the questions, we were talking about what is the strength of the intermolecular forces as you compare. If you are comparing alcohols and carboxylic acids, which one is stronger than the other one? Carboxylic acids are stronger because they have two sides of hydrogen bonds, and then alcohols will be weaker because they have one side of hydrogen bonds as compared to the two. You also need to compare the energy needed. What did we say about that? If you have a stronger intermolecular force, you will need more energy to overcome the intermolecular force. If you have a weaker intermolecular force, then you will need less energy to overcome that intermolecular force. And furthermore, do not forget to conclude on the physical property, meaning you must conclude to say, is the boiling point or the melting point or the vapor pressure going to be higher or lower? Once you are able to do that, then you don't forget to mention the compounds and the intermolecular forces about on that particular question, and talk about the compounds on that particular question. I hope these tips are going to assist you when you are looking at the relationship between the physical property and the intermolecular force. What do you look at? You look at the chain length, you look at the surface area, you look at the molecular mass. You also need to be able to look at the type of the intermolecular forces that are present. Okay, if there are different types, you should know how to identify the different types, then compare them, then talk about the energy required. If they are from the same intermolecular force or same homologous series, you look at their chain length, you look at their surface area, then you compare the strength of the intermolecular force to say, as the chain length increases, the strength of the London forces will increase, like in the example that we looked at earlier. All right. I hope you guys are still with me. Let us look at the next tip I want to give you. The next two tips I want to give you, let's focus on the first one. The first one is the tips when you are answering the trends. Okay, they can ask you in terms of the trends in the boiling points or the melting point, as well as the vapor pressure. All the time when they talk about the trend, that means you are looking at substances or organic compounds that belong to the same homologous series. If they belong to the same homologous series, what must come into your mind is that you must look at their chain length or their surface area or their molecular mass. So the longer the chain, the higher the melting point, the higher the boiling point, the lower the vapor pressure. Okay, remember that. Okay, the other thing that I want you to remember as you're answering the question, you will say carboxylic acid have more sides of hydrogen bond than alcohol. So all the time when you compare the strength, you specify the intermolecular forces that are present. Okay, for example, I might be comparing an alkane. Say I'm comparing an alkane with a carboxylic acid. What do I need to do? I need to compare the strength. I already know that side is London forces, so I must say weak London forces. That side I can say stronger two sides of what? Of hydrogen bonds. Or I can say carboxylic acids have two sides of hydrogen bonds that are stronger than the alkanes. So all the time you must compare, and when you compare, you must indicate that what are you comparing with. You don't just write the statement as it is. The stronger the intermolecular force, the higher the boiling point. I already said that. That is the relationship. The weaker the intermolecular force, the stronger the vapor pressure. Remember that, because the vapor pressure, it's actually, the relationship is vice versa with the boiling point and the melting point. The next tip that I want you to look at is, what do you need to do when you compare? Which comparative words do you use when you are doing this? Because the most important key, remember I said you talk about the intermolecular forces present. You compare the strength. As you compare the strength of the intermolecular force, which words do you use to compare? And when you talk about the energy, which energy? You don't just say there will be more energy. More energy to do what? You must specify. More energy will be required to overcome the strength of the two-sided hydrogen bonds. Okay, so it's very important to be specific. So which comparative words do you use in the relationship between the intermolecular forces and the physical properties? You will talk about longer or shorter chain. The longer the chain, the stronger the intermolecular force. The shorter the chain, the weaker the intermolecular force. You can talk about more or less branched chain, okay? The more branched it is, so the weaker the intermolecular force. The less branched it is, the stronger the intermolecular force. Stronger and weaker, okay? As you are saying, as you've been hearing what I was saying, you talk about strong, you talk about weak, all right? That is very important. The other one can either be strong, the other one will be weaker. More or less, I've already spoken. Stronger will go with more energy. Weaker will go with less energy. And also higher or lower. When you say higher or lower than in terms of the boiling point, in terms of the melting point, in terms of the vapor pressure. Excuse me about viscosity. In your chapter, you do not do viscosity. It's only about the melting point, the boiling point, as well as the vapor pressure. Now that we have done that, now let us conclude. Let us summarize our lesson. I've already given you the exam tips of what is it that you need to do when you deal with this question. Now let us summarize our lesson. What is it that we looked at? We looked at the different types of intermolecular forces. We said that different homologous series belong to different homologous series. We said our AAA, there is our AAA, alkane, alkenes, alkynes. They all belong to London forces. Another word for London forces, it can be dispersion forces or the induced dipole forces. Whichever word that your teacher has taught you is correct, okay? And then what do we know about that? They are the weakest intermolecular forces, and they will require low energy or less energy will be required to overcome the intermolecular forces. And then when there are lower intermolecular forces, when there is low energy, we know that the boiling point will be lower, the melting point will be lower, and the vapor pressure will be higher. Very important to remember that the vapor pressure will be high. Then we spoke about Hake. Our Hake, how do we write Hake? Hake. Why Hake? You have your haloalkane, there is your haloalkane rather. You have your aldehyde, there is your aldehyde. You have your ketone, there is your ketone. You have an ester, there is your ester. So your Hake consists of what? Of your dipole forces. Now remember, the dipole forces also consist of the London forces. London forces plus dipole forces. But because dipole forces are stronger than the London forces, those are the ones that become more dominant in organic compounds. Then what do we know? They will also have low energy if you are comparing the three of them all at the same time. But if you are comparing dipole with London forces, we know that they will have high energy. And then the higher the energy or more energy is required, the higher the boiling point, the higher the melting point, and the lower vapor pressure. But if you are comparing dipole with hydrogen bonds, then they will have low energy, meaning that will be a lower boiling point, lower melting point, as well as a higher vapor pressure. Then lastly, we looked at the A as well as the C. We said these two are your hydrogen bonds. You still remember we spoke about hydrogen bonds, all right? Then we said between the two, the one with the strongest hydrogen bonds, it's carboxylic acid, because they have two sides of hydrogen bonds. And remember, the stronger the intermolecular force, the higher the boiling point, the higher the melting point, and the lower the vapor pressure. Again, I just want to cancel out viscosity over there, cancel out viscosity over there. All right. I hope you guys are still with me and you are following with what we are summarizing with you. Remember, the higher the boiling point, you will require more energy will be required to overcome the intermolecular forces. Then we further said, what happens if the examiner gives you substances that belong to the same intermolecular forces or they belong to the same homologous series or functional group. What do you compare? You look at their structure in terms of the chain length, okay? The chain length. So what did we say about the chain length? We said as the chain length increases, the strength of the intermolecular forces increase. Therefore, the higher the boiling point, the higher the melting point, and the lower the vapor pressure. And more energy will be required to overcome the strength of the intermolecular forces. All right. Again, we said the shorter the chain, or the shorter branched it is when we are looking at the branch chain. So what is it? What that you must know? Then the intermolecular forces will be weak. It can be weak London forces, or it can be weak dipole forces, depending on what the examiner has given you. Which homologous series did he or she give you? All right. So remember, the weaker the intermolecular forces, less energy will be required to overcome the intermolecular forces. And if you require less energy, therefore you'll have a lower boiling point and a higher vapor pressure, but the melting point will also be low. So let's quickly include lower vapor pressure. And basically that is all about the summary of today's lesson. I hope you have learned a lot in today's lesson, and you will go and attempt to answer different question papers in relation to this activity. Now, for just an overview to take you over on what is it that we have done. Remember, we have looked at the physical properties of organic compounds, such as the melting point, the boiling point, as well as the vapor pressure. We said the relationship is the higher the boiling point, the higher the melting point, the lower the vapor pressure. We also looked at the relationship between the physical properties as well as the strength of the intermolecular forces. The stronger the intermolecular force, the higher the boiling point. The weaker the intermolecular force, the lower the boiling point. All right. And then we said we have 3 intermolecular forces that we need to know. The London forces, okay, which is your dispersion forces or your induced dipole forces. You also need to know the dipole forces, and lastly, your strongest is your hydrogen bond. And please do not forget our AAA Hague AC. Okay, AAA is your London forces, Hague is your dipole forces, AC is your hydrogen bonds. So that is going to assist you as you are dealing with this chapter. We also looked at the concepts of physical properties. We also gave you the tips on how to answer the questions, which words you must use as you answer these questions. Guys, thank you so much for tuning in today's lesson. I hope you enjoyed yourself and you have learned a lot from this lesson. My name is Dimpho Rampora, and thank you so much for joining in.